With the overhang test, one of the things I noticed was that as the print head was moving between the uprights, it was stringy. And I think that might have been related to temperature. Perhaps the temperature was a little bit too high, which was causing the plastic to be a little bit more fluid, which basically meant that it was stringing between the uprights. And I did try it with retraction in order to try to prevent stringiness. So what I'm thinking is that perhaps it's temperature that's the problem. Now, rather than printing the same test with lots of different temperatures, the same overhang test, what I thought I'd do is I'd create a new test in Blender so that I could actually test whether it would be stringy between uprights, but also whether it would still be stringy if the temperature changed. So basically I'm putting together this model at the moment. I thought I'd start recording here just to show where I'm up to and kind of the idea I have. So essentially we've got a base so that we can stick something to the bed, and then the idea being that we've got 3 uprights. So just like in the overhang test where we had uprights, it's going to move from upright to upright. But then I thought, actually, if we're doing this, I might as well test other things at the same time. So I've got basically a cube that I extruded or changed the vertical dimensions so that it was very tall, and then we've got a cylinder, and then I created a circle, and then I gave it 10 vertices, and then I shrunk 5 of those, the alternate vertices, inwards in order to create a star shape, and then basically just kind of extruded them or extended them so that they're all the same height, and then they're stuck to the base. Now the reason why this cube's here is because one of the things I still haven't quite got my head around blender units and how many blender units relate to a specific size in the real world. But what I do know is that how big the artillery test cube is. So by importing the artillery test cube, I'm aiming for something that's basically twice as high as the cube and then just over the same width. So I don't want it to be too big so that I'm not effectively using too much plastic or filament, but also I want it to be big enough so that there's enough scale there to test things. So it's kind of a balance between not too big, not too small, and just right so that we can test a number of different things in one go. So not only are we going to test the stringiness between the columns as the print head moves backwards and forwards, but also what I wanted to test was at this size or this resolution of print, if you like, how accurately it would print a tower, a square tower, a circular tower, and also the challenge of the fine detail of a star shape. But then what I thought, whilst I'm at it, what I'll do is I'll also implement, because we might as well test a number of things here at the same time whilst we're testing temperatures, and that is to test an overhang. So it's not too much of an overhang. It's not like with the previous overhang test where I was going from 0 degrees, 10, 20, 30 or to 120, but it would be interesting to see how this slight overhang is reproduced. So basically I've added this what started out as a cube here and then extended the length, and then I created a cylinder and extended the cylinder outwards so that we've got it kind of more of an oval shape, and then I'm going to create a boolean to exclude this shape from this to then give us our overhang. And then what I'm going to do is I'm going to put a text label at the front of this section to indicate what temperature it is at that section. And then I'm going to basically go from 230 to 180. Now, when I was looking at the different temperatures of the filaments, they seem to be in the range between 190 and 220 or something like that, 215. So I didn't want to go too hot to make it too fluid. So I didn't want to go to like 240, 250, but also because they seem to start about 190, I thought I won't go any lower than 180 because I don't want it to clog the print head or cause any problems if it can't extrude. So I thought 180 to 230 would probably be a sufficient range, a sufficient temperature range. So my idea is to duplicate this section, and then we'll have 230, 220, 210, 200, 190, 180 rising up the column. And then what I'm going to do, I could one could do it manually as one is watching the print, to actually override the printer and reduce the temperature as it's going further up the tower. However, what I'm going to do is I'm going to work out where the layers change, and then modify the G-code file to override the temperature whilst it's printing. And that way I don't have to sit and monitor it. I can just let it run and it will do the temperature changes automatically. So I'll cover that a little bit later. So essentially what I'm going to do now is I'm going to continue with my model and build upwards, duplicate these areas. I'm also thinking about creating a bit more of a challenging test. So what I've done here is I've actually got this cutout through the center of the tower. So basically I duplicated this. I Control C for copy, Control V for paste, and then I reduced the size of it but kept that central position, and then I used again another Boolean to cut out the center square from the outer square. So that basically gives us an empty tower or cavity inside, and then I thought I'd do the same with the circle or the main cylinder in the center. Now I'm not quite sure what the outcome's going to be, and I've also cut it from the base as well, just so that when it's finished printing, the idea being that we can see through the center of the tower. Now I'm not sure how successful that will be, but I just thought if you can see down and you can see, because this is going to be changing temperature and the filament's going to be more fluid at the bottom than it is at the top. Well, that's what I'm expecting, logically based on the temperatures. I just thought it'd be interesting to see, be able to look through the tower if possible, and then see what the outcome would be and whether you get an idea of how the smoothness changes. But also what I thought I'd do is I'd add some like textures or some cutouts or something to this square tower, so that we could actually get an idea of the accuracy of the print using different challenging cutout methods as we go. Anyway, so I've got some ideas in mind, so I'm just gonna, rather than spend the next hour or so making you watch me do all of that, I'm going to stop the video here and then come back to it when I've got it a little bit more complete. So I'll see you in a bit. So here we have the completed temperature tower. Now the main objective of this test is to test the temperatures and test the different print temperatures and see how the filament changes as the temperature changes. But I've gone a bit mad and included as many tests as I could in terms of let's see what happens as the temperature changes based on different aspects of the print. So not only have we got our original 3 towers, we've got our cylindrical tower in the center, our star-shaped tower on the right, and also our cube or square-shaped tower on the left. But what I've done is I've put in our logo on the base. We've got basically gradients within the tower. Now the idea of this is, as I go through working out what layer I would like the temperature to change, I'm actually going to start the change where we've got this little dimple in the cylinder. So essentially what I did here was I created a sphere and I positioned that sphere within the cylinder itself, and then duplicated the sphere at equal increments, and then created a collection, and then I used a Boolean modifier to cut out those spheres from the central column. So that gives us that little dimple. So the idea is, as I go through the G-code file working out the layer changes, I'm going to change it from here to 230, to here to 220, here to 210, so that basically it's got to temperature by the time that it's going to start printing this block with this overhang. Now bear in mind that the print head's going to be going left and right between the 3 towers, so it's going to be really interesting to see whether there's stringiness or how much stringiness there will be based on the fluidity of the plastic at the time that it's extruding. So that helps me prepare for the temperature change. We've got the labels that have been cut out from the front of the block, so that where you've got the actual temperature, you know what temperature it was at that time, and we'll be able to see how clearly it can cut out, or the printer can print that cutout of the temperature as well. And then if we go round, we've got the overhang itself. Now obviously this isn't a full overhang test, we're only testing it out to this point, but it's going to be interesting to see how smooth that is, that curve, at that particular temperature. There's a slight overhang there. Now that's intentional because I wanted to see where that lip of the overhang, where it starts, I wanted to see how accurately it can reproduce that. I think it's going to be really interesting because as you've got the main central point, which is obviously quite thick, but then you've got these points which are actually very thin. So I think it's going to be really interesting to see how the printer copes with the very small resolution of the tip of the star. And then if we come round now, actually I'll get rid of this cube now because that was just there as a visual size indicator. Now on the inside of the main left column, I've left it smooth because I think it would be interesting to see how smooth it would be at the different temperatures as it's increasing higher and higher. At the front of the tower I've got just a cutout. Basically all I did was to create another column or another cube and then extend that to be a column, and then basically use another Boolean modifier to cut out that basically what is a straight line. So it's effectively a vertical straight line test to see how different temperatures affects that. Then on the right hand side I created another cube, extended it so that it was thin and narrow, and then basically duplicated it at equal intervals again. I created a collection and then used another Boolean modifier to cut out that entire collection from the tower. So as we can see, we've got these vertical cutouts. So again, it's going to be really interesting to see how the printer copes with the resolution or the small cutout shape, and also how it's going to cope printing that at a slant cut out from the main tower as it increases in temperature and height. And then if we go right to the back, what we've got here is we've actually got part of our logo. Basically it's text. I wanted to see how well it would accurately reproduce text at those temperatures. So we've obviously got our logo printed as a cutout from the base. So it's going to be about, I'll start it off at 200 degrees there. So that's 200 degrees temperature. Then what will be a real test is how it's going to print the text at the different temperatures as it goes up. So again, these are just duplicated at the same height, distance, if you like, from each other as the cutout, so that's all equal, rising up the tower. And we'll be able to see, using these indicators with our overhangs, at what point the temperature is at that point as it rises up the tower. So again, it's kind of a cutout test, accuracy test, text test, shape test. It's so many tests in one. I hope it's going to kind of be just like the best all-round test I can think of that for each filament. And then what I'll do is I'll print each filament that I have using this same tower, and then I'll be able to get an even more accurate indication of the ideal temperature test, or the ideal temperature to print for that filament from this test. So obviously I've done all the test cubes, and that was really a good test, I think, especially initially as I was getting used to the machine, to be able to see how the filament would come out. So, you know, a 3D representation of something in plastic from that filament. But this is going to be the best test. So this is going to really help me understand not only the machine better, what it's capable of, how accurately it can print at certain resolutions, but also how effective the filament is at a particular temperature in reproducing detail, accuracy, that type of thing. So really interesting test, and I can't wait to get printing with this, and then we'll see what the results are. So here we are in Ultimaker Cura, and I've imported the temperature tower model I created in Blender. Now, one of the things I needed to do, or ensure I did when exporting from Blender as an STL file, was making sure that selected only was selected when exporting as an STL. If I didn't select only, it would select everything, including the objects that make the cutouts, so it appears as like a solid block and you don't have all these cutouts. So by selecting the whole model and then selecting selected only, you basically export it with all cutouts as intended. So if I go around the model, you can see we've got our star on the right side, we've got our central cylindrical tower, we've got our little dimples, we've got the blocks with the overhangs and the temperatures, we've got our logo in the bottom, and if we spin around we can see that we've got our central line cut out, our graduated cut out slices up the side, our 3D on the back, and we've also got the overhangs. Now, just as we saw with the previous overhang test, what Cura is doing here is it's indicating that this is an unsupported overhang, and it shows it in red. Now, one of the things I'm very keen to do is to test the level of overhang success at that particular temperature. So the previous test with the overhang, that was all at the same temperature but at different gradients or angles, whereas this one, it's all about testing at different temperatures with the same angle. So I've got the settings here as part of the print profile, and many of these settings I've just left as default as they were previously. If we go into custom though and go through them, so our layer height I've just left at 0.12mm, seem to be getting success at that particular super quality layer height, and that's what the original Cura profile gave me. We've got our thicknesses, our infill density at 20%. Now, even though the print is going to effectively be at 230 degrees by this point, I wanted to start it off at 200. I've been doing most of my printing at 200, and I know it's going to stick to the bed okay at that temperature, and I know it's going to start off okay at that temperature. So what we'll do is basically modify the G-code file so that it starts off at 200, and then we'll work out the temperatures based on where it needs to be at a particular point, a particular layer. The build plate temperature, 60 degrees, again, that's kind of been the standard I've been working with, and I know that everything sticks at that temperature. And then as we come down further, one of the things I wanted to do is just making sure that as it was, because one of the things that I think could be a problem with stringiness is if it's not retracting the filament between the towers. So I've made sure that retraction is enabled. Cooling seems to be on in most of the prints that I've used anyway, so I've left that 100%, and that seems to work quite well. I don't want to include support because I want to test the level of the overhang as part of the natural print without support, and we've got the build plate adhesion type of skirt. I think in the previous video I referred to it as a brim, but actually it was skirt that I was using. So these are the settings I'm going to use, and then we'll see how it comes out. So I'm going to click on slice now, and we'll get an idea of how long this is going to take. So there we go. So it's actually going to be 2 hours and 55 minutes. Now, I suppose when you think about it, even though it's not a particularly big print, 49.7 by 16.4 by 47.8 millimeters in size, there's still a lot going on. So there's a lot of detail it needs to reproduce. There's a lot of challenging items here for the printer to print. So it's kind of no wonder it's going to take 2 hours 55 minutes. It would have been interesting to know how much extra it would have taken if I hadn't included all these cutouts, including the gap in the central towers, because not only would that have added to the print time, it would also certainly make the weight greater than 4 grams, and that it would require more filament, more than the 1.48 meters is going to take to print this test. So what I can do now is save to disk, and then what we'll do is we'll modify the G-code file manually once we've worked out the layer heights and which temperature needs to be at which particular point. So here we are in Repetier, which came on the memory stick with the Artillery Sidewinder X1 3D printer. Now, it might be that Cura can do this already, but I'm still getting used to the software. So I know that Repetier can do this, and I know how to use Repetier when doing this, so I'm using Repetier, and that's basically to look at the G-code file and work out the layers where I need the temperature to change. So I've loaded the G-code file in Repetier, and we can then look at the model, and if we zoom in we can see, just get it to a point where we can actually look at it in more detail. So there we go. So So we're starting off at 200 degrees, which is within our print file already, and then we're going to go 230, 220, 210, 200, 190, 180, and I've put in these little dimples so that we can indicate or work out where that as an indicator where the temperature needs to change. Now I'm also modifying the GCode file here in Notepad++, and what this is going to allow me to do is basically to go to the particular layer and then change the print temperature, or the hot end temperature, the print head temperature at that point in preparation for the next level. So this is set the temperature, and then this is wait for the temperature to be in effect before it continues printing. So basically set it, wait, then go. So I'm going to copy that section there, and then we can use that in a second when we come to the next section. So first thing we need to do is we need to work out the layers. Now if we go into edit G-code and then we go into show layer range, what this allows us to do is build the print and then work out what layer we want to be at. So if we come down to there, so that's about the start of our dimple. You just about make it out there. Just zoom in a bit further. There we go. So the dimple's there. So if we come down a bit further, so that's about there. So that is layer 27. So what we need to do is go to Notepad, and we've got here layer 0. So if we highlight that and press Ctrl F, that's find. So if we then go to layer 27, so layer 27, and there we are. So what we can then do is we can do that, and then we can set that to 230, and that will set the temperature to 230, wait for the temperature to be 230, and then continue to print this next section, which we want to be at 230 degrees. And there's the dimple for the next level, and that's, we don't need to get it absolutely exact, it's just really an indicator. That's about there, and that's layer 91. So go back to our file and search for layer 91, and then Control V, and then we'll change that to 220. So at this level it's changing the temperature down to 220, and they're going to continue once it's got to that temperature, and then it'll print the next section at 220. So then when we get to here, so again just where the dimple is, about there. So this is going to be 152. So go back to our file, search for 152, and then paste that in, and that's going to be 210. And then go back to Repetier. So it's printing this next section at 210, and then when we get to the next dimple, just about there, a bit more. That'll do. So that's 212. Go back to our file. 212. So this is going to be 200 degrees, so it's back down to what the base temperature was originally. Back to Repetier. Keep going a bit further. I'll just move this down. So that's 200, and then we've got our little dimple there. So now, so that's layer 272. So find 272. There it is. Paste that in, and this is going to be 190. Go back to Repetier. So it's printing this next section at 190, and then we look for the next dimple, which is just a little bit fiddly to get it accurate there, but that's okay. So this is 337. So this is our final temperature of 180 degrees at 337. So 337. Paste that in, and we're down to 180, and that's our final temperature, our final print temperature. So we'll save that to make sure it is saved, and then if we just follow this up, so there we go, so that's going to be 180 all the way to the end. And it's a really good way of visualizing how the printer is going to print, because here we can see the infill density of the block as it's building it, and then as it's going up. So it's really interesting to see how the printer is going to be printing each layer. But that's essentially it. So we've done all our layers, we've done all our temperatures. So we've saved the file. So now we can write this file to the memory stick and then transfer the memory stick to the printer and then start printing. So I'm really looking forward to this bit and really looking forward to seeing how it'll come out. So here we are in time-lapse mode, and as I mentioned earlier, the original print time was around 2 hours 55 minutes, and even in time-lapse mode it still was over 10 minutes in length. So I've increased that to 10 times speed, and we can see it basically printing the model in front of us at a much improved speed. Now everything was going well. I kept going back to check on the model every 10 minutes or so, and it was building the base nicely. It was getting all the initial layers okay for the towers and the uprights. Everything seemed to be going well. I could see that it was changing the temperature at each graduation within the tower, and everything seemed to be going fine for probably around probably 2 hours. So it's probably around 75% complete, and then something unexpected happened, and in hindsight I probably should have considered that this would happen, and that is, it fell over. So thankfully I returned to the machine literally just as this happened, so we can just see that there's a little bit extruding, but thankfully I managed to stop it and not waste too much filament. But essentially what I should have considered is that because the base was quite small, the overhangs actually give it weight on one particular side, which means there's nothing to balance the weight, hence it fell over. So in order to try to reinforce the model, I went back to Blender and I increased the base size so that we have a base that's wider. So I increased the width, and I also added a little extension here by using another base, duplicated the base and then reshaped it. So the idea being that the base in itself gives more support for the towers, but also this sticky out bit here gives extra support on this side in order to support the weight of the overhangs. So that's the idea. So not only did I need to make the adjustment to the model in Blender, I needed to re-export it as an STL, making sure that selected only was set, and then import it into Cura, then export the GCode file, and then modify the GCode file so that I got all the temperature changes at all the different levels I previously worked out. And then I could put it on a memory stick and take it back to the printer. So let's see how that comes out. And here we are back in time-lapse mode. Now the original print was 2 hours 55 minutes, and now I've increased the size of the base, that's even longer. The time-lapse recording was over 20 minutes in itself, so I've sped that up by 20 times so that we can actually get through the majority of the printing process much more quickly in around 30 seconds or so. And it's building the base, it's doing really well. I've been going back and checking on the print probably about every 10-20 minutes. Everything seemed to be fine. It got much further than it had previously. The structure itself hadn't fallen over, which was brilliant. It was getting higher and higher. I was checking the temperatures on the display panel for the Sidewinder, and I could see that the temperatures had all taken effect each time. So it was going up the tower, it was getting lower in temperature. It was on the last block that was about 180 degrees, and then something unexpected started to happen. The center tower had started to topple over, and again, upon reflection, or in hindsight, I probably should have thought that that tower itself is kind of unsupported. So even though the model was unbalanced previously, that central tower was effectively unbalanced, and presumably also with the temperature changes that are at each level, there's probably something to do with the the model's own adhesion to itself. So as you get a layer change from 230 to 220, there's probably almost a weakness in the model where the temperature has changed. So it's really interesting going through this journey, because I'm definitely learning about the machine more, but also this almost the science of working with plastic. And I hadn't considered that the model might be weakened at those different levels initially, and also I certainly hadn't considered that the overhangs would weaken the model or unbalance it. And I guess one of the things I realised with this is that supports aren't necessarily there to allow the overhang to print. They're actually there to allow the model to be supported whilst it's printed, so that it doesn't fall over as the plastic is still quite malleable or quite hot or warm, so thereby weakening the model further. So as I continue this journey, I'm learning more and more things about how to print. And in fact, the interesting objective here was to test printing temperatures and the stringiness. And whilst I allowed myself to get carried away with all the different tests we could do, I've kind of taken myself off that original track by adding these overhangs, which then basically unbalance the model, which caused the print to fail. But the amazing thing about the model is the detail, the level of detail in what it was able to print before it toppled was brilliant. You could make out the slashes in the tower, you could make out the print, the 3D text, and you can make out the temperatures right at the beginning. You could make out so many aspects of the detail that I put into the model, and even the overhangs are really smooth on the underneath. It's done brilliantly well. It's just a shame that it was affected by the weight of the middle tower, because it was effectively unsupported at the bottom. So interesting and a helpful insight into how everything works, which will allow me to print better in the future. So I realise this has been a long one, but it's been a very interesting learning curve for me, and I hope in some way it helps you. So I'm going to embark on part 2 of the test, which is going to be a simpler model testing what I wanted to test originally, and that was the stringiness of different temperatures between the 2 or 3 towers of this particular model.